So now, the question says, given the regression lines represented by the regression equations 8x minus 10y plus 66 is equal to 0, and 40x minus 18y is equal to 214, find the mean of x's and y's, then correlation coefficient, the standard deviation of y, if that of x is equal to 3, find y when x is equal to that, find x when y is equal to 5. Let me explain what this is trying to tell us. It means there is data that was given, and the analysis came up with these models, regression models, to be the ones that could fit the data very well. So that means you could be able to predict any of these by saying maybe if, for example, x is equal to something, then y will equal to some value. The same. So these two may be lying on the same graph and they are fitting a particular data. Now, to get the mean of the values of x and the mean of the value of y, remember these two lines are on the same graph. So if they are on the same graph, you'll find that to get their mean, the mean of the values of x, the mean of the value of x will be at a point where the two are going to be intersecting. The same way is how we get the value of the mean of y. Also, remember we are saying these are two lines. So if they are intersecting at a particular point, you will have a value, a point that has x and y. So the y value at that moment is going to be the average of the values of y of all these graphs. Then the value of x is going to be the mean of the values of all the x values on these two graphs. So here I'm saying I'm assuming that this is a Cartesian graph and these lines maybe have been drawn. So if these lines are plotted on this graph, you'll find they intersect at some point. So where they intersect, it will be the y bar and the x bar. So the two regression lines are intersecting at x bar, y bar, and that is the very first observation that you have to make. So we already said we have equation 1, which is 8x minus 10y plus 66 is equal to 0. So that means I can make this 8x minus 10y is equal to negative 66. And that is equation 1. Then I can also have 40x minus 18y is equal to 214. So I can use a calculator and determine the values of x and y. Or I use a elimination method and be able to determine that. So if I'm to use the elimination method, I can put here 5 and then multiply so that I make this 40. I'll have 40x minus 50y, which will be equal to 66 times 5. This is negative 330. So I have 40x minus 18y is equal to 214. So I subtract. When I subtract, this is going to be minus 50y, then minus minus. So it will be plus. And this is going to be 32y, which will equal to negative 3, negative 330 minus this. Remember, this is going to be minus because this is negative, like negative 50 plus 18, which is negative 32. So you have to do that subtraction very well. So what is this? This is going to be plus 214. So I will have minus negative 544. And what is the value of y? This divided by that, we will be good to go. So the answer is 17. So what is x? X should be, if I can use equation 1, that will be negative 66 plus 10 times 17 and divide by 8. So negative 66 plus 170 divided by 8. What is the value? So 170 minus 66 divided by 8. The answer is 13. Therefore, mean for x's equal to x bar is equal to 13, and for y's equal to y bar is equal to 17. This is very important to note and actually easier to do, because the moment you see two regression lines and they have told you to calculate the mean values for x and y, then just solve the two equations simultaneously, get the values of x and y, and then those will be the mean values. And that's very simple. You can even use a calculator and get those values. So what is the correlation coefficient? To get the correlation coefficient, this is how we are going to get it. Now, if you have this equation equal to mx plus c. C is the y-intercept, the value of y when x is equal to 0. M is the slope, as we earlier on said. But this slope is also called the coefficient of correlation, or the correlation coefficient. The correlation coefficient for x. Okay. Let me say, okay, let me elaborate. This is going to be the correlation coefficient of x. Okay, correlation coefficient of y Regression coefficient of y on x. Okay? Correction coefficient of y on x. Now, if I make here the x the subject of the formula, so that maybe I have x is equal to, let me say this was m1, so that I have maybe m2 y plus maybe c1. Then m2 becomes the correlation coefficient of x on y. Because remember, if I have this equation, x 8x minus 10y plus 66 is equal to 0, I can express this in terms of x is equal to, I can express x in terms of y, or express y in terms of x. Now, if I express this equation, x in terms of y, then what will I get here? The coefficient that I will get will be the slope, for the graph of x in terms of y. If it is y is equal to that something times x plus a constant, then that will be the slope of the graph of y in terms of x. So we are building a concept which is going to help us to answer the above problem. So let's proceed. Now this correlation coefficient, this correlation coefficient of, for example, y on x is also equal to r sigma y sigma x, and sigma y is the standard deviation of y. Sigma x is the standard deviation of x. Then the correlation coefficient of x on y is equal to r sigma x sigma y. And the definition of sigma x sigma y remains the same as we have already said. So I repeat, to get the correlation coefficient of x on y, we said you have two equations. The two equations, each express it, one express it in terms of x, another one express it in terms of y. Now look at their slopes. The one which is in terms of y, look at its slope. The one which is in terms of x, look at its slope. Then those slopes, if I multiply those two slopes, and each slope, remember, is the equivalent to the correlation coefficient. For example, the correlation coefficient of x on y, the correlation coefficient of y on x. If I multiply the two, each, for example, equal to, one equal to r sigma y sigma x, another one equal to r sigma x sigma y, you'll find that I'm getting r squared. And this r squared is what is going to give me the general correlation coefficient of this regression. Okay. In the style we express our equations in the style I'm telling you. Now we have 8x, okay? We have 8x minus 10y equal to negative 66. So express it in terms of x, okay? So that you have 8x plus 66 equal to 10y. What do? We divide by 10, both sides, by 10, by 10. So y is equal to by 2, 4, by 2, 5. We have 4 out of 5x plus this by 2, we have 5 by 2, 33. So we have 33 out of 5. That is our equation. So that will tell you that here, maybe this is m1 is equal to 4 out of 5. And this is the same as sigma y divided by sigma x. This is the correlation coefficient of y on x. Y on x. Y on x is y, which is on this left hand side, on x, which is on the right hand side. Then there are the other equation which are express it in terms of x. So the other one is express 40x minus 18y equal to 214 in terms of y, so that you have x the subject, x subject of the formula. So what does that mean? I have 40x equal to 214 18y plus 214 divided by 40 divided by 40. My x is equal to 18 by 2. I have 9 divided by 2. I'll have 9 out of 20 times y plus 214 divided by 40. Or if you wanted to also divide it by 2, this is 107. So you have 107 divided by 20. So this gives you M2 to be 9 out of 20. So M2 equal to 9 out of 20 is the correlation coefficient of x on y. X on y. X, which is on the left hand side, and on y, which is on the right hand side. Now, the correlation coefficient, okay, for the regression will equal to, we said this is equal to r squared, and we said is the same as okay, is the same as having this sigma y sigma x times sigma x sigma y, and this is the same as us having that m1 times m2. So r squared is equal to what we already have is 4 out of 5 times 9 out of 20. This one by 4 1 by 4 5, so you'll have 9 out of 25. So what is r? R is equal to root of 9 out of 25, which will be 3 out of 5. And therefore, the regression correlation coefficient will equal to 0.6. But this 0.6 is positive, okay? R is equal to positive 0.6, positive because M1, M2 are all positive. If one of them was negative, then this R becomes negative. Okay, there is no way how you could take square root of a negative, but all of them could be negative, so that you have a negative times a negative and you have a positive. So if you take square root, you would have R being positive. But generally, once you finish doing that, you have to conclude that your R is equal to negative 0.6, because M1, M2 each were negative. So that you say you have a negative, maybe a negative correlation coefficient that is substantial, or you have a low or a very strong positive or negative correlation coefficient. So that's why the value, the sign of the correlation coefficients, first of all, when you're dealing with them here before, matters a lot, because at the end of the day, it will determine the conclusion that you're going to make on whether the correlation coefficient is positive or negative. Now, as we said, we have already gotten the correlation coefficient. We have already gotten the means for x and y. Our task now next is to determine the standard deviation of y if the standard deviation of x is 3. We said standard deviation of x is equal to 3. That of y, we don't know. But we already know, correlation coefficient of, for example, x. Okay, let us take that one of y on x is equal to 4 out of 5 and is equal to r sigma y sigma x. This definition we had earlier on given it up here when we were starting to analyze this problem. We said the correlation coefficient of y on x is r sigma y sigma x. Correlation coefficient of x, which is the same as the slopes of those curves, of those lines when rearranged. So for x on y is equal to r sigma x sigma y. But we have already determined the r. So we need to get sigma y because sigma x is given. Therefore, 4 out of 5 is equal to 0.6 times sigma y divided by 3. So this was 4 out of 5 equal to 3 out of 5 times sigma y divided by 3. This and that will go, this and that will go, and sigma y is equal to 4. So the standard deviation of y, standard deviation of y is equal to 4. So that's how you can attempt this problem. Now, to find the value of y when x is equal to 10, you just come to this equation. N of the equations, value of y when x is equal to that. You just determine it from here. Then the value of maybe x when y is that. You just substitute in any of those equations. But for this problem, for this exact problem, you can see x and y were defined for you. So y is equal to that. So you do, to determine the value of y when x is equal to 20, you substitute in this equation. To determine the value of x when y is equal to this, you substitute in this equation. And that was the only trick. But if they are given to you like this and they don't, I mean, if they are not given like this and they have mixed them up, then you can just choose arbitrarily which one is maybe your equation 1 and which one is equation 2. So that equation 1 maybe you express it in terms of y is equal to something. Then the second one, you express it in terms of x is equal to something. And that's all. So any question before we can break off?